In this lesson, we are going to talk about asymptotes: vertical, horizontal, and slant. The first type are vertical asymptotes. If f of x equal to p of x divided by q of x is a rational function in which p of x and q of x have no common factors, and a is a zero of q of x, the denominator, then x equal to a is a vertical asymptote. So let's look at an example. In this function, we have f of x equals x plus 3 divided by x squared minus 9. So the first thing that we want to make sure is there are no common factors. So we would want to factor anything that is factorable. So in the numerator, nothing can be factored, but the denominator can be factored to x plus 3 times x minus 3. So we would be able to reduce this fraction by canceling out the x plus 3's to 1 over x minus 3. So the new denominator is the one that we're going to use in order to find a vertical asymptote. So we take x minus 3 set equal to 0 and solve it. So our vertical asymptote for this function would be x equal to 3. All right, the second one are horizontal asymptotes. Again, if you have a rational function where the degree of the numerator being n and the degree of the denominator being m, the following can be used to find horizontal asymptotes. So the first one we have is if n is less than m, so if the degree of the numerator is smaller than the degree of the denominator, then the x-axis, or y equal to 0, is our horizontal asymptote of our graph of f. Second, if n equals m, so if the degree of the numerator and the degree of the denominator are the same, if they're equal to each other, then the line of y equal to a sub n divided by b sub m is the horizontal asymptotes of the graph of f. So here we're just using the coefficients of our numerator and denominator. Third, if n is greater than m, so the degree is larger in the numerator than the degree of the denominator, the graph of f has no horizontal asymptotes. So I have three different examples that I want to look at. So the first one, you notice the degree of the numerator would be 1, and the degree of the denominator is 2. So we have that the degree is smaller in the numerator than the denominator. So in this case, our horizontal asymptote would be y equals 0. Second one, the degree of the numerator would be 2. The degree of the denominator is also 2. So in this case, they are equal to each other. So I'm going to use the leading coefficient of 4 and the leading coefficient of 2 to determine my horizontal asymptote. So in this case, 4 divided by 2 is 2. So I have a horizontal asymptote of y equal to 2. The third example, the degree is 3 in the numerator and 2 in the denominator. So because the degree is larger in the numerator than the denominator, we say that there are no horizontal asymptotes. Third, the slant asymptote occurs only when the degree of the numerator is 1 more than the degree of the denominator. Again, only 1 more. If it's more than that, it doesn't happen. So in this case, when we have the example f of x is x squared plus 1 divided by x minus 1, the degree of 2 in the numerator is 1 more than the degree of the denominator. So what we do is we take the denominator and use synthetic division to find our equation. So I'm going to have 1 on the outside. On the inside, I'm using the coefficients of the numerator, so 1, 0, 1. And applying synthetic division, I get that I have an equation of y equal to x plus 1 plus a remainder of 2 divided by x minus 1. But when we talk about slant asymptotes, we don't worry about the degree, or excuse me, we don't worry about the remainder. So in this case, we only use x plus 1. So here is my equation of my slant asymptote. Okay, so let's look at an example where we have to find all three, vertical, horizontal, and slant asymptotes, if any, of the given equation. So I have the equation x squared minus 4x minus 5 all over x minus 3. So the first thing I want to do is figure out my vertical asymptotes. So I'm going to factor the numerator. And I'm doing this to make sure that I have no common factors so that if anything cancels out, I want to get rid of it first. In this case, there are none. So I take the denominator, set it equal to 0, and solve. So my vertical asymptote would be x equal to 3. All right, the second one, the horizontal asymptotes. Again, remember you're using the degrees of the numerator and denominator to find them if there are any. Because the degree of the numerator is 2 and the degree of the denominator is 1, I would have no horizontal asymptotes. And the last one, the slant asymptotes, I'm going to use my synthetic division to see if I have any. So I know I have one because the degree is 1 more in the numerator than the denominator. So again, placing 3 in the outside, my coefficients of 1, negative 4, negative 5 on the inside, using the process of synthetic division, and remembering that I do not need to use my remainder, I get the equation of y equals 1x minus 1. Here is the graph of the function that we just looked at. And so you can see there is an imaginary line where the graph never crosses. That one there is considered our vertical asymptote of x equal to 3. Also, there is another imaginary line, kind of in this direction, that we just found called our slant asymptote. That is your y equals x minus 1, that the graph also never crosses. So you can kind of visually see what we have found in the previous problem.